This is whereby you usively. So how to set up webhooks on our platform. So if you go to africastocking.com, on your account, you can either set up webhooks for SMS, voice, airtime, SSD. Any few products have that feature enabled. Then over here we have your application layer. This is how you set up and build your application. And then the API calls, this is the integration layer. How do you combine Google Gemini AI and also Africa Stocking? So making outbound calls, inbound calls, sending SMSs, and also doing voice control. Then finally, the data layer, this is where you persist data to your DBs and also your cloud storage. So let's say, for example, for voice, if you're storing audio, you will be able, those S3 files, those audio files, you can store them on S3. So, while approaching module 1, I'll just go back to the notebook, and I've already covered that section. So, the architecture design. So I'll focus a bit on voice and how you can easily build out your system using voice and also combining it with Gemini. So we have 3 typical scenarios that you can approach it. So this can be the turn-based approach. So the turn-based approach is whereby I make a call to maybe your service. Let's say, for example, it's a customer care application. So I'll make a call to your service. Then that call will be redirected to AT. Then AT will send it to your callback. And then since Dagi mentioned voice and USSD are bit dynamic applications, so you build out the experience however your business logic requires it. So voice and USSD are typically quite dynamic, so you use the callback to create experiences for your users. So by building out dynamic systems. So as I was saying, so a user will call your system. That flow will go from AT to your webhook, and then you start processing the information. So if you look at this example over here, a customer calls an AT number. So I'll just go quickly to my account so that you can follow along. You just go to your Africa Stocking dashboard. Then if you don't have a number, so because over here you already see I have a number. Then if you don't have a number, you quickly request for one, and it will be provisioned for you for testing purposes, unless you are doing some production-ready applications. So come here, set up your callback event, callback URL, and also your events URL. So for this session, I won't set up my events URL. Okay. So that's the process of just getting a number and attaching a callback for it. So a customer calls an AT number. So an AT number is a number that you have been issued with. So you can either virtualize your company's number or you get an actual phone number. So then AT will send a webhook to your server. So that's the URL that you have put over there. Then your server will respond back with XML. So XML is basically that structured markup language. So we have here an XML response over here saying, welcome, how can I help you? So in this session, we'll be building out a small customer service application. This can be like a small, like when you call Safaricom, how do they respond to you? Typically something like that. So over here, we'll ask you, how are you? So, and tell you to, so record an issue that you are experiencing. So then AT will play the welcome message, and then, so when a user has called your number, so let me go back to the flow again. User will call your number, AT will send a webhook to your number, to your will send a webhook to your server, then you'll respond with an XML. Then AT will play that XML to the user. Then, since in that message you have a recording session, a recording action, will record the audio from the user, send it back to your server that you have your callback URL for your server. So you'll continue with that process, like it's a whole loop until until either you terminate or the user ends the call. And before that, so when you receive the audio, you'll process it and either send it to Gemini for processing, so that you can get back a response and respond back to your user again. So it's a whole cycle, but there are, as I've mentioned, there are three approaches that you can take. So the number one is the turn-based approach. So the turn-based approach is whereby I send a request, I wait back for the AI to respond, typically that whole journey. So I have a simple image to demonstrate that. So I'm not sure if it's visible or not, but the whole journey is you have the customer over here, they'll make a call, send the webhook to your server responds back with the XML, and then over here, if we look closely, we'll see when you receive the audio from the server, you'll download it and send it to Gemini. Then Gemini will process it, send back an appropriate response based on the query the user was asking, and then you can either persist on the storage layer and then respond to the user until that flow ends or that loop terminates. So the second approach on how you can, so there's some few issues with this approach and some pros and cons. So the pros are like, this is a simple way of getting started with Gemini and Africa Stocking. So there's no webhooks, there are no WebSockets involved. It's pretty much straightforward request response type of structure. It's easy to debug. You can easily test it out with Postman. So you saw Dagi making a call directly from the browser by just sending a request. So you can either test that out with like Postman. Reliability. So it is going to handle the call recording on our side and then return back the URL for the recording, and then it's cost effective, doesn't require a lot of resources, it's easy to set up and easy to debug. So the issues about this approach, it's the latency involved. So can you imagine you want to have like a human-to-human type of conversation while interacting with an AI. So not that whole process whereby I record my issue, wait for a few minutes or a few seconds, get back a response. So that latency is so much, and the user experience is not the best. There's no interruption. So like if I had a query on an issue, I have to record the whole message and wait back for a response. So as I've mentioned, the user experience is not the best. It's not engaging, and so we'll see how we can improve this experience. And for this simple example, what it's best for is typically like for FAQs, if you want to build a simple customer service whereby you just send your issues and get back a response. And also, what else? Mostly data collection, and also if you want to build out an MVP just to validate your prototype. So we'll just see how this process flows again. I think there's something missing. I think I'll just go back here again. So we've seen how the turn-based happens, and then we look at the second approach, which is call conferencing. So has anyone ever used the call conference feature on their phone? Call conferencing. So call conferencing is basically, let's say I'm calling Dagi, and we are just basically just discussing some issue, and then we are like, maybe someone in a different team might have some context, and you don't want to drop off from this call. I can add someone to the call, so I can dial their number and add them to the same call that we are in, and now we'll have like a call conference, and we can discuss the issue, the three of us, or even you can add multiple people on your call. I think this feature is available on every device, if I'm not wrong. So that's the second approach that you can take while building out this feature of whereby you want to combine voice and Gemini. So this typical structure is I'll create a call conference, and then I'll join the call conference, and now I'll enable Gemini to join my call conference via a SIP client. So let me just showcase the diagram so that we can easily follow along, but I'll explain the step-by-step process again over here. Try and enlarge that. So we have the customer over here. The customer will make a call to your number again. So this is the number AT has issued. So the call will reach AT's voice gateway. Then we'll send a webhook to your server again. So while what is it called? When on your server, when you're processing this information, you will return back an XML for joining a call conference. So if you look at our documentation, so this has been easily documented. So just go to the call conferencing feature on the call actions. You'll see all the information regarding how to join a call, play music, mute even people in the call. All that information is available. So this is mostly just a quick brush through. So when you receive the join call conference command, so we'll create the call conference, then we'll proceed to enable the user to join the call conference. Then we'll dial into the call conference. That's step number 6. So this is your SIP client. So not your SIP server, it's a simple SIP client. Then it will enable, it will join the call conference as a participant. This will be in place for Gemini. So when you go to number 7, we'll receive customer audio. So when a person is speaking within the call, we're able to receive that information and process it with Gemini directly. So this enables, what is it called? That back and forth bi-directional communication by the different participants in this call, whereby we receive that information. So we are connecting to Gemini via WebSockets, sending or streaming that audio directly to Gemini, and also receiving the response back from Gemini. That whole flow to enable that real-time communication. So we can review this step-by-step journey again. So a customer will call AT. AT will send a post to your webhook. Then your server will respond back with an XML for creating and joining a call conference. So we'll create Okay, so we'll join the call conference, and then we'll create a room. So the room is whereby people will join and will join the room. So the customer now will join the room as a participant. Then your server will programmatically join the same room, and then this will enable now that bi-directional communication audio flow that I was mentioning. Okay, then now we'll connect Gemini as a participant, and then we'll stream this audio directly to Gemini and also receive responses from Gemini. So Gemini also returns an audio stream, so we'll receive this audio stream and play it to the user. So that whole step-by-step loop will proceed until either the user is satisfied with their issue has been resolved, or now we can either escalate it to a human agent. So the pros of this approach is, so the latency is reduced. So the initial one was more likely like turn-based, whereby I send a recording and expect back a response. So this one is much more better because you send, you're communicating with Gemini at the same time and also receiving back responses. It's bidirectional, and the architecture is flexible because your server or Gemini now joins the conference as a participant, and also you can add multiple people in this call. So you can have Gemini, you can also have another human agent available in the call, either to monitor and see if Gemini is providing the correct responses, or in case there's an issue whereby it's unable to respond, they can chime in and respond to the issue. So one, it's a bit complex to set up, but if you easily go through the documentation, it's a bit clear. It will help you to build out this whole user flow. And then, so there's also some bit of lag whereby you need to stream that audio to Gemini and also for it to process and send back a response. But it's better than the turn-based approach. And also, debugging also increases in terms of complexity, because now you are trying to debug audio streams, but you can easily resolve that. So when is it best for? So if you are building out a professional customer service, so not the previous one whereby you just send back information and expect back a response. So if you have either interacted with the new Safaricom customer service, you will get to a point whereby, can't remember their, is it Zuri or something? So Zuri will respond to your issues until whereby you feel like it's unable to respond, and now you need a human agent to assist. So that whole flow whereby there's that point whereby Zuri will allow you to interrupt, or you can interrupt it by also providing more context. And then finally, there is approach number 3. So approach number 3 is the real-time WebRTC or SIP connection. So has anyone ever interacted with WebRTC? So I think this is a bit complex. I think I'll skip that section if you haven't interacted with the WebRTC. So the previous ones are a bit more flexible, since there's the request response. I'm pretty sure most of you have interacted with REST. So REST is the request response type of structure, and also since also for the call conferencing, WebSockets. Has anyone interacted with WebSockets? Socket.io, that whole structure around is easily approachable. So for this, so this number 3 approach, the real-time one, is whereby you are directly streaming to Gemini. So you can either use SIP, so you can either get a SIP trunk from Africa Stocking, a SIP connection, and build out that whole flow, or even just use WebRTC to stream directly to Gemini. So WebRTC is the same technology that is used in these video conferencing tools like, is it called Google Meets, Zoom? They typically use that same technology to enable streaming. So you need like a media server, like Janus and everything. So, but it's a bit complex to set up, but when you do that, that whole process is simplified. I'll skip this approach first, but it's very, so the steps you can typically see the steps are quite a lot to enable that bidirectional real-time connection. We also have that image or that flow. It's quite huge because you can see we require like a media server, you require a free switch if you're either using SIP for connecting. But for this one, we'll focus really quickly on approach 1. So the first approach is the simplest that you can easily build out. I'll just showcase the structure that you can easily use. So over here, we can see the user calls AT. AT will send a request to your webhook. Then you can create a session, then respond back with a greeting. So the user will receive the greeting, and then they will be asked to provide a recording. We record the user's audio, download the audio, send it to Gemini, and then expect a response. Send back a say response to your user, and that whole loop continues until you either terminate the call or the user ends the call. Context switching a bit, but you will bear with me, kidogo. So that's the initial design or architecture that we will think through, and then we'll really brush through the rest really quick so that we can build out our system really fast. So we have already pictured the architecture that we want, and now we'll see a few things that are required to ensure that your system is going to be safe and secure while building it out. So we'll quickly go through module 2, which is best practices. So I think this one has been mentioned a lot out there by a lot of speakers, and maybe if you are different, if you watch even tutorials, authentication and authorization, this is whereby you need to enable users to authenticate to your system. You need to provide or allow them access to specific parts of your system. That's authorization. So over here we saw Rogers adding authentication to his system. It was really quick using Firebase Studio. So authentication, and also authorization. So you can easily utilize Google Secret Manager to secure some of your credentials. So this is a simple example of whereby you can store your Africa Stocking credentials, your username, your API key, those secrets. You can either store them on Google Secret Manager and also utilize Google Secret Manager to load and access your credentials in a secure way. So number 2 is environment-based configuration. So how do you configure your variables? Do you put them as plain text and post them on GitHub, or do you use like envs or application confs? And then we'll see. So when on your system, the user input, do you validate it, do you sanitize it, or do you accept any information being sent to your system? So you need a way of validating the user inputs so that users cannot put in malicious input and either trick your AI to doing some nefarious or um, unintended processes. So one, you can validate the user input, you can validate their phone numbers, you can validate if they are trying to manipulate your system by either if you have like regex enabled and for either text-based system if you're using like SMS. So we have seen some ways of securing a system is authentication. You have also seen how you can secure your system by using environment-based configuration, not leaking your configs to everyone, and also validating and sanitizing your user input. And also another thing is rate limiting. So rate limiting is limiting the number of requests being sent to your system. So this is part of preventing denial of service attacks. So when users are trying to hammer your system, you can tell them like, hey, cool down and reject some of their requests in case they have exhausted the number of requests within a time window, or whichever process you will use to enable rate limiting. So you can use like window-based within a certain time frame. If a user sends more than, let's say, 100 requests in a second, you can whitelist them and you can whitelist them and prevent them from accessing your system for a certain period. Then another approach of securing your system is data encryption. You can either encrypt it at rest and also encrypt it in transit. So, well, at rest, this is whereby when you're storing it or persisting it in the database, you can either encrypt some sensitive information like PIIs, users' personal numbers, their IDs, what else? Anything that can easily tie back to a user, you can encrypt that while storing it. So that's encryption at rest. I have an example over here. So this notebook is available. If you received the email, you can check out the notebook. That's module 3 and look at some of these examples. So that's encryption at rest. And then option 2, so we have encryption in transit. So, well, you need to enable your system to have HTTPS. So securing your information while it's in transit and not leaking any, or when a user is trying to access it via HTTP, just redirect them to HTTPS. And then also over here, we'll cover quickly module 3. So this was building out the voice application. We already have an architecture in mind. So we are building out the simple service that we thought of. So over here we'll create, let me just use this one. This one seems like the structure has been okay. So we have a full implementation of this system. So you can utilize my example while building out your system. Or if you have any question, you can either raise your hand and I'll respond to it. So over here, we have our call session service, or call session actor is basically in charge of handling all your call sessions. So your session needs to be unique for every user. You create that. Then we have a call supervisor. So we have, uh, spinning up your call sessions services. We need a way of managing, in case one goes down, need a way of enabling it up again. And also, in case our call ends, we need a way to terminate or remove that session. So then we have our webhook service, whereby we'll receive the webhooks from Africa Stocking, process it, and relay back the information to our users. Then over here we have our voice service, whereby I think Dagi mentioned XML. So over here we can create our simple XMLs. So when you want to say say something to the users, so we can put in some say actions. So over here we have our say class. We provide the text that you want to speak to the user, and also the voice that you want to use. So over here we can use a woman's voice and then respond back to the user. Then we also have this, we can combine multiple actions together. So over here we have a way of combining two. So we can either say and record. We'll provide the say action and tell the user what we want to say, and also let them know that we are recording them. And then you also have the call transfer. So the call transfer action is whereby, in case your AI is unable to respond, you can dial another number and transfer it to, or let's say you're in you have called a bank and they are will transfer you to a different department. You can easily utilize these transfer features. But all of these have been documented on our API. So if you look at our documentation, so you can look at the different actions available. So you have the say action, the play action, we have the get digits. So the get digits is whereby you want to receive the input the user is inputting on the keypad. All of those actions are available. So, or even you can use the call actions to combine multiple actions together. Over here you can see this example. The user is saying, you can play and also dial another action. You can combine multiple, even like 3 actions in a same request. And then here we finally have our Gemini service, how we connect to Gemini and how do we send our requests to Gemini. So over here we have our function whereby we transcribe with Gemini. So we receive the audio bytes string, encode that, and then send it directly to Gemini. You can either use the SDK, but for this case, so the SDK basically just wraps around the HTTP request. So, but for this case, since there is I was using Scala, I didn't have time to find the Gemini Scala SDK, so I'm doing it directly. So I'm sending a HTTP model. So over here, you specify your Gemini Pro model, and then so I think you are shown how you can access your API key. So you can easily go to AI Studio and get your API key, and also enable billing. So attach your API key over there, and then over here on the entity, so the request body. So this is the audio that you have received from the user. Send it to Gemini, and then expect back a response. So over here, we are extracting the response from Gemini and then converting it to text. So over here, we have this function that basically just transcribe that audio. So whereby we download the audio from the URL and then process it with transcription. All of these code examples are available on this repo, or you access this, what is it called? This collab. So then you can either test it out using ngrok. Dagi showed you can either use Cloudflare or if you want to test it out locally, you can use ngrok and use the URL that ngrok has generated as your callback URL on the dashboard. Then to validate your system is working, you can write some tests to ensure that everything is okay. So typically that's the whole process that that we were building out. So I'll go back over here really quick to showcase it again. So our system is able to handle session management and also audio downloading, and also Gemini, and also sending it to Gemini for transcription and also for processing, and also persisting the necessary information that you want. So we have seen how you can generate the webhooks and also how you can consume the webhooks. So all of these examples are available. And if you had time, I could have run the application and see it in action. So over here on the webhooks integration, we have the voice events and also so this is for the events, and also we have for the callback. So we have seen how you can test and run it. And then finally, we have the SMS one. So for SMS, it follows the same process or the same design. So a user will send a message to your shortcode. So the shortcode is either like a number that you have been issued with by Africa Stocking. So a user will send a message to the shortcode. So then AT will post it to your webhook, then get the context from that message, send it to Gemini, then expect back a response from Gemini, and then send back the response to the user via SMS. And then continue that whole flow until either the user stops responding, or the response is sufficient. So the key differences between SMS and voice approach is that it's asynchronous in nature. So the user doesn't require a response immediately. So a user can wait for a while to get back their response. So then option number 2 is that it can handle longer processing times. So for voice, it requires an immediate response. So if I'm sending a request to Gemini, I expect a response immediately so that I can proceed to ensure that my queries have been resolved. Then it's easier to implement because it's multi-turn. So when I send a request and I expect back a response later, it's quite easy and to implement. So using webhooks, Dagi mentioned that. So I'll just scroll down to how we implement this. So on the SMS implementation. So a user will send a message. So the webhook is triggered from Africa Stocking side. Then we process that request with Gemini, then send back a response to the user, and either log the interaction and also persist it to the DB. So over here we have a SMS implementation. I'll try and zoom in a bit. So we have the different messages to process the message, get a Gemini response, either if it failed or it was successful. So then we'll create a session for while communicating with Gemini. So you want to ensure that a message that you send is easily responded to the same session so that we can keep it quite interactive. So we'll receive a message from the user, process it, send it to Gemini, then we'll receive a response from Gemini, and then we'll construct a message. So over here we are sending the message with Africa Stocking to the user again, and complete that whole cycle or flow. So over here, the same case, you need to set up webhooks. We have our webhook service over here in the SMS routes, whereby we receive incoming messages, process them, send them to Gemini. So over here, we have our message handler. We'll process the message, send it to Gemini, and expect back a response. We also have the delivery reports. We want to know that messages that we are sending are being received, and then we continue to process and handle them. So we also have a Gemini service that we are sending SMSs to. So another thing is that while responding to a user via SMS, we want to ensure that the message is concise. So you don't want to send like a huge text back to the user. So if you are asking, let's say, a certain question, we want Gemini to either return back a concise message. So we have a function to either split the messages, or if you want to send back a long response to the user. So you can either chunk it, or so if you're chunking it, it's better for the user experience rather than just receiving a huge response. Then now we have covered the 4 initial modules. So number 1, we covered how to architect and design our system. Number 2, we covered some of the best practices that we need to put in mind while building our system. Then number 3, module 3, we covered how to build out our voice AI implementation. Then we have quickly seen how you can build out your SMS AI integration with Gemini. And then finally, we'll quickly cover a section on API versioning and lifecycle management. So this is basically how you, what's it called? How you version your APIs and how that whole lifecycle management is handled. So when you build out your system, you need a way of versioning it. So you can either use like API versioning, you can have different versions, combine different versions and make them available for users. So over here you can see I have like 3 different versions and all of them are being accessed. So there are a couple of things that you need to put in mind. So why this matters is because you need to add like new features without breaking existing client code. So like if we are using, let's say, Africa Stocking version 1, and either when we introduce a version 2, we want to ensure that the previous version 1 works perfectly without interfering with the new version 2. Also, we need to ensure that we deprecate old endpoints gracefully. So we need to set like a sunset date. So the sunset date is typically the period whereby we'll stop support for the previous version. And also, how do we support multiple versions simultaneously? Like in this example over here, we can have 3 versions running at the same time, each version supporting different processing and different services. And also, we need to ensure that your users, let's say, for example, if you're using Microsoft, so Windows version, version 10, and now there's version 11, Windows will typically let you know that they are stopping support for Windows 10 in this period. So we need users to migrate to version 11. So that holds that whole life cycle. So as I was saying, there are 3 different ways of doing versioning. So you can either do URL-based versioning. So I've shown this example whereby you have like v1 in the URL, or if you look at our examples in our documentation, if you look at, let's say, SMS, for example, in the overview, we can see, okay, while sending a bulk SMS, over here you can see API, Africa Stocking version 1. That same design, you can version them effectively the way you want. So number 1 is URL-based versioning. Then number 2 is header-based. So if you have interacted with systems like Stripe, Stripe typically uses header-based versioning, whereby you provide the versions in the headers. Then we'll quickly, so I think, so let me see this content for deprecation. So as I was saying, when you're supporting multiple versions, you need a way of ensuring that you relay the information on when you're going to stop support for the previous version. Let your users know. You can either put them in the headers or either attach it in the response that user is receiving, and let them know that deprecation is coming, when it's going to happen, that whole journey. And then you need to ensure that your system is backward compatible. When you're either on version 1 or version 2, they need to easily communicate with each other. You can easily have a way of either converting V1 to V2 or from V2 to V1. I have some few examples on how you can do that over here. And then finally, we have feature flags on how you can. This is mostly while doing deployments. If that feature is enabled, you can do that. So module 6 is typically cloud deployment and scaling. So we have seen how we have architected, how we have built out our system, and how you can manage that whole life cycle of using versioning. And now we need a way of our users to access our system. So you can either use Google GCP or you either use Cloud Run. So for my example over here, I Dockerized my application using Docker. I have my Docker file over here. I'll build my, what's it called? My Docker image. And then I have my configuration. So this is similar to your NPM package management. So I have my dependencies, the different versions. Then, so I've built out my system. I need to deploy it. So I created a simple script that connects to my Google project. So, and then build it, then deploy it to Google Cloud Run, then run it. So I also configured Cloud Run with auto-scaling configuration. So in case there's a spike in users, it can either auto-scale or downscale, depending on my configuration. And then finally, load testing. You can either load test with K6 or even Gatling. So I typically use K6 or Gatling to either load test my system to ensure that it can handle the different the different spikes or the different loads from different users accessing the system. Then finally, we create our CI/CD pipeline. So you can either use GitHub Actions, or if you use Bitbucket, you can use Bitbucket pipelines to, while doing the deployments, it can automatically run your your script and deploy it automatically. Then finally, you have deployed your system. You need to ensure that you're able to monitor it, ensure that you are able to access the logs, and view the metrics of how your system is running. So you can create your logging file over here. So if you use Java, so you can, or Scala, you can use logback, or you're using Node.js, you can either use, is it Winston or Wilson? Winston, yeah, or Signale, all of those. So configure your logging, and then if you want to receive a metrics on how your system is running, you can either configure Prometheus or whichever or like tracing, uh, receive how your system is, receive the different metrics of how your system is running, how users are interacting with different parts of your system, and also you can use it to measure latency between different parts of your system. Then you have the metrics. So here you can either plug in like Grafana to view your metrics, analyze the data from your system to help you in case you want to, what's it called? You want to explore features on how you can optimize your system. You can either utilize those metrics from the logs or from Grafana or Prometheus, just to help you analyze and ensure and help you know where you can easily optimize your system. Then finally, we have our production checklist. Ensure that all your API keys are stored in a secret manager. You can either use Vault or Google Secret Key Manager. Ensure that your system runs on HTTPS. Then ensure that rate limiting is enabled to prevent denial of service attacks. Then ensure that inputs have been validated on all endpoints. Then also for webhooks, so to ensure that not everyone is spamming your webhook, ensure that you have webhook signature verification enabled. Dagi talked about HMAC, HMAC signature verification. You can either use like whitelisting for the services that you expect webhooks to come from, or use that webhook signature verification. Then enable monitoring, so ensure that Prometheus metrics are exposed, Grafana dashboards have been configured, and also alerts have been enabled. And then for performance, ensure that load testing has been done and completed, auto scaling has been configured, and also DB indices or indexes have been optimized. So while either writing or reading from your DB, ensure that that has been done. Finally, ensure that you either have like a caching strategy enabled. So in case you have like frequently accessed data, you can cache that. And also, or maybe even configure like a CDN. So whereby users can easily access from different regions, can access information really fast. Then for reliability, so you need to ensure that you have health checks. So you can have periodic health checks to ensure your system is up and running. Then you also want to ensure that you have graceful shutdown. So this is whereby you need to close all, maybe if you're using a DB, you can close your connection. You're using different services, you can close them up while shutting down. Then finally, we also have circuit breakers. So circuit breakers is mostly for external services. In case maybe you're using an external service, let's say you have a payment system and requests are failing to that system, you can enable circuit breaking, so to enable it, to ensure that errors do not propagate to your system. In case an external service has failed, or when it's returning errors, you don't want those errors to propagate to your system and cause a cascading failure. So you need to enable circuit breaking. In case multiple retries to that system have failed, you can either close out that connection for a certain period and also retry it later. Then we can enable retry logic. So with exponential backoff, that's called jitter. So if I'm retrying a service and it's continuously failing, so I increase the frequency of how much I want to try. So if I try after 1 minute, so if I typically retry after 1 minute and that fails, I'll either continuously increase that backoff. So so the next time I'll retry is either after 5 minutes. So even after 5 minutes, that process is failing, I'll probably now retry again after 10 minutes. So increasing that, so because you don't want to continuously retry a service that's failing, that's making your system unreliable, and also increasing resources that are typically not being consumed. And then finally, dead letter queue. So for those requests that are failing, you need a way to have a log of all those requests that are failing and either process them manually or retry them automatically. So you can have a queue for all those failed requests. Then finally, we also have compliance. So this is in line of our production checklist. So for compliance, ensure your system is GDPR compliant with all the data policies. So you can look at the data Office of the Data Protection and see what they say about that. So you also need to ensure that call recording consent is handled. So when you want to record someone or you want to record an audio from the user, you want to ensure that they're informed before the recording, because users can come back and claim that you record them without their consent. Enable that before. PII encryption at rest. So PII is the personal identifiable information. So any information that can be tied back to the user, you need to ensure that while storing it, you store it either in an encrypted way to ensure that in case a hacker or someone accesses your system illegally, is unable to make sense of that data. Then you also have audit logging enabled. So audit logging is whereby when a user performs a certain action, so that information is logged. So in case you want to replay some steps performed by a user, or you want to know who performed this action, you need to enable audit logging in your system, such in case an issue occurs, you're able to trace where it happened and who performed that action. And also terms of service, ensure that you have your terms of service and privacy policy published. So these are what your system does and how does it do it. In case you're collecting data, you need to tell the users you're collecting the data and what you're doing with this data. So in terms of compliance. Then finally, you have completed building out your system, you have secured it, and then you have finally deployed it after going through your checklist. So over here, we can quickly cover what we've learned in this whole session. So how you can design multi-channel AI systems. You can combine either voice and SMS. So you can either use SMS as a buffer. In case either your voice service is failing, you can redirect them to using your SMS service. And then we have seen how you can easily integrate Google Gemini for natural language processing. So using either webhooks, either calling it directly. We have I've shown you those examples, and you can either look at this to if you want to refer back to it. Then we have also covered how you can implement security for your system. Then finally, we have also seen how you version your APIs properly, if it's either header-based or URL-based. We have seen how you deploy to Google using, so you can either go to your Google account. So just go to cloud.google. Okay, it is. So go to your console. I think there's something wrong with my internet, but yeah. So can deploy to Google Cloud with auto scaling. You also seen how you can set up comprehensive logging and monitoring with Prometheus and Grafana. And then we have also seen how you can typically create CI/CD pipelines using GitHub Actions. And then we have prepared our production checklist and our best practices. So next steps, so use the examples that I've shown here to work on your projects. So these are going to be the capstone project, or you can use it to create mini or sample applications, experiment with Gemini, try out the different models and different parameters. So you saw on my request, I was using Gemini Pro. You can use different models to do different things. Add more channels. You can either use WhatsApp, you can either use USSD. Then finally, join our community, share your builds. So in case you build or those badges that you receive, share them on our Slack channel, and then share it with the community, collaborate with different people, and build out your systems. So over here, I've attached some resources. So Africa Stacking documentation. So if you need access to our documentation, you can either Google it or using this link, access the documentation. Check out Gemini docs, check out Cloud Run, and even Prometheus. And in case you have an issue, you can either reach us on Slack, open an issue on GitHub, and then we'll check the discussions. And then finally, happy building. Have a good time building these systems and have fun. Collaborate with each other and ensure that you're able to collaborate effectively. I think I'll be coming to the end of my presentation. And in case you have any question, I'll open the floor. So I'll check the ones online. You can send your messages, but I still have an issue accessing the chat, but that's okay. Yeah. So if you have any question regarding Gemini, yeah. So for garbage collection, so it depends. So if you're, so let's say for this example over here, so since I was using Scala, it has GC enabled by default. So it's the part of the JVM languages. So it does that garbage collection for you, but you can optimize it. So how you can optimize it is, let me see if I have an example over there. So when we go to our deployment, so when we are building our jar file, so you can see over here when we are running it, this section, try and zoom it. So you can configure how you want to do garbage collection. So they usually have different variants, so you can put in different configurations. So for this, I have this set. So use G1, GC. So this is my current configuration that I'm using. So it depends. So let's say for different languages like Node or Python, they don't have garbage collection. So if you're using languages that do that for you, like I think Go does garbage collection, if I'm not wrong. So I'm not quite familiar with that language. So I'm mostly on the JVM languages, or even if you're using compiled languages like Rust, or even C, or even C++, that one doesn't, that one is, they don't do garbage collection. Or what were you referring to garbage collection? Or like shutting down resources and closing connections? Yeah? So typically languages, I've shown you like that configuration will handle garbage collection automatically for me. So I won't, so it's either, and I'm closing, so graceful shutdown, I'm either closing out my connection, my DB connection, closing out connection to external resources. That's what I can typically do when I'm shutting down my service. But when it's running, that GC process is handled automatically for me. Yeah. Is there any other question? So if there is no further question, I'd like to thank you and appreciate you for your time. And thank you for participating and being attentive. So I'll be handing it over to Ben for a quick he'll be able to go through the AI bit really quickly as we conclude the sessions for today. Let me welcome Ben. I don't know if he's available. Thank you, and thank you for your time. Okay, we'll take a 5 minutes break as Ben sets up.
food at the back there, but it seems that the people responsible are not here at the moment. Okay, that's that. I think you're stretched up now. I'll try to be a bit fast for this session because it's like a whirlwind of things that we're going to talk about. And this covers a notebook marked 7 to 10 within the links that was part of the blurb that you may have come across. So, okay. Yeah, so I know people have been talking about AI and stuff like that, and some of you are software engineers, and maybe this paradigm is not something that you're used to, and maybe let's just take a step back and cover some fundamentals which could help you as you grow your journey as in this machine learning, artificial intelligence space. So, when you're writing like classical programs that you're used to, there's a certain paradigm you use. Like there are some rules you come up with. Like for instance, if maybe it's a sign-up page you're coming up with, and there's a certain information that you take in and then put in a database. So that covers the rules and data. And then when someone actually completes that process, you've pretty much solved the problem, right? That's like something that you guys have been exposed to. But when it comes to the whole machine learning, which is a subset of artificial intelligence, and this is also the workflow that you'll probably go through, is you give this algorithm that you're using, like some data and a couple of maybe labeled examples of what you are trying to do or what you're trying to achieve. Maybe you're trying to classify dogs from cats. And if you give this maybe neural network that, it'll come up with ways of identifying those cats and dogs as an example. So it comes up with the pattern of how to figure out what's a cat or what's a dog, which some of you like are pretty good at this point in time. And for this section here, this covers like something called the neural network architecture. Like just a typical maybe classification problem where you have, like let's take the example of deciding whether it's going to rain tomorrow as an example. So you get data from the past, which you have to transform in a numerical form. Because when you give these systems things like that kind of data, they don't just take data like in raw form, like text or other kind of things that you're used to. They mostly take in numbers. So if there's a way you can convert your data set into just a bunch of numbers, like it can be in a matrix form, those are rows and columns of numbers, or it can be just like a single string, a single array of numbers, right? And then once you have that kind of situation, you give it to a neural network, and then it's going to transform it in a particular way, depending on how you wrote your whole architecture. And then once that data is transformed, you basically have a situation where you have to compare the label that you have, if maybe it's going to rain tomorrow, or whether it's not going to rain. And if you find that data is close to the true data when it comes to, oh no, yeah, so there's a section where once the data is transformed, we are trying to find how far the data is to the true data. And if that signal is very small, that means your model is doing well. And this loss score that you get, which is a number, it goes to the optimizer, and there are parts of that equation that we are calling the model, which is a kind of equation, either something called coefficients or are updated, and pretty much you have a formula to solve the problem, which is predict how the weather will be tomorrow. So I have a question for you between these two diagrams over here. Imagine, yes? Where are we? How do you share your screen? How do we do it here? I don't think I have access to share my screen. Okay. So I have a diagram over here. Don't mind the equations over there. And let's just say you want to make a road. Let's say the red line is the road. Which one would be the best configuration you would use to make sure this red line is closest to these settlements, which are the blue points over here? Is it this first one or this second one? Can you see this? Can you see this? Can you see this there? You can see this. Okay. Yeah, yeah. Can you see that? Okay. Now? Oh my. Okay, back to our question. So, imagine the red line is a road and the blue dots are settlements. Where would be the best place you would put the red line? Is it the configuration on the right or the configuration on the left? Don't mind the equations there. How many say to the left? Just raise your hand. So, imagine the blue dots are settlements. This is where people live. And the red line is a road. Where would you put the red line so that people can access the road better? Is it the first configuration, which is the first graph you're seeing to the left, or the second one, the graph you see to the right? So, how many choose the one to the left? Is it my left or okay? This one to the right, this one to the left. Or this one to the left, or this one to the right. It's different. Okay, how many choose this one? How many choose this one? Okay. So, for the longest time, for very many models, at least the ones that we made in the past, it's easier to give something with a smaller formula that you're seeing, like this one, this proper fit here, because some of these are things that explain why it's going to rain tomorrow. It might be humidity. It might be it can be humidity, it can be temperature. Let's say maybe that corresponds to this and that corresponds to this. Could be. And then this second one, where you have all this very long polynomial or this equation here with about 10 coefficients here. It's a bit hard to explain what's going on, but given how we are with large language models, I think it's moving towards this one that has a very long equation. That doesn't mean it's wrong. It's just, it's a bit difficult to explain such complex formulas, but I think with time we'll figure out this, and then maybe instead of preferring this, we might go to this. So there's no right or wrong answer there. So for the bulk of my presentation, I'll show you some of the ways people used to do, how people used to use like ML, and then just typical machine learning tasks, and then move to how they're doing them with Gemini, with a bit of introduction to agents, model context protocol, and hopefully the new things to do with agents, like agent to agent protocol, and agent to payments. Yeah, but that one I'll just go through it like superficially because this is a lot of content. Yeah. So I think for the setup of like your Google Cloud environment, I think this has been mentioned in the past by other speakers throughout the day, as well as there's some information here that you can reference. And I saw someone asked about the notebook. So I think if you guys could send that, it would be nice. Yeah, so that we finish this on time. Okay. Okay. So, usually when I'm going through my notebooks, I usually like learning like what kind of environment I'm running. And here, like if I run this, I'm using Ubuntu 22.04, and that's important because like some of these notebooks go to production, at least some steps, and it's often good to know this because when you're choosing your runtime while you're using Docker, it's always good to have this like the same as what you have here on the Colab. And I don't know if you guys have noticed, like you can just click here to deploy to Google Cloud Run. I don't know if you, but if you scroll down here in runtime, around the periphery at the bottom, you can be able to see that. Okay, it is not zooming, but that's okay. Okay, so another thing I do is I check out what is installed in this environment. Here, I'm just going to look at if there's anything, any package to do with Africa Stalking and Google Cloud. And Google Cloud, we have the majority. There's Africa Stalking now because I already pre-run this notebook. That's why it's here. But most of the time it won't be there because you're probably running it in a new environment. Then here I install some dependencies. Here I confirm the dependencies and who actually wrote them. Because sometimes you may expect like, hey, this has been written by someone or by some group that I trust, but you may not be the case. So it's kind of good to look at this just for security's sake. Right. Also, for the dependencies, I normally put them in like one place because there are these things like when you're doing a lot of like data science or machine learning, where there's this package called NBDev, where it can help you like transition between notebooks and Py files really fast. So if you have everything organized like this, it's easier for you to transition between notebooks and Py files. So that's why I do something like this. But sometimes when things get hectic, I'll move my dependencies elsewhere. So these are dependencies to help with making like widgets, using Africa Stalking, and some of the Google related packages that will help us do a couple of things. Then this top part is regarding loading and transforming data, but I don't think I can go through this part, but the links there will suffice to give you an introduction, and you'll be able to transform data and prepare it to do a couple of tasks. So we'll start with the Cloud Vision API, which has utilities to help you make sense out of images. Things like, so these ones are mostly governed by things called convolutional neural networks. And Google has a couple of curated models that can help you do these particular tasks. So label detection, it can be, you give it an image and then it tells you, oh, this is a cat, this is a dog. Mostly, I think this is curated from the ImageNet dataset, which is just curated images of a couple of things that are going on online. And there is the face detection, just detecting people's faces, then optical character recognition. Maybe you want to figure out what's going on in a couple of like receipts that you have and then load that information to a database or maybe object storage for further processing. So here we'll need that service JSON file that you generate in your Google Cloud account. And this is just a way of like just showing your ID so that you're able to use these services. And this is going to be stored in my environment over here. If you check the file system, it's over there. And keep this file safe. It has very sensitive stuff. But you can also store the same file within this key icon here, which stores your secrets. And here are some of the secrets I have, and they have been obscured. So you can also copy paste it as a key value pair here, and you can be able to access it as you're going through the notebook. Oopsie daisy. Okay, So the first one, I load in some utilities to help me analyze an image that I got from one of the Google Cloud Storage. And it's just a picture of a cat. Let me just show you guys. So this is the image of a cat with this caption here, wake up human. And basically we're gonna use the utilities that we just loaded in to see whether the computer is able to figure out what's going on with this in this image. So if we run that, we see that it was able to label, that was a cat. This is the scientific name associated with it. It's a carnivore, that's true. And all these other categories here. So this might come in handy, especially maybe for recognition tasks, like, for instance, maybe you're trying to figure out what cell this is, and this can be, or systems like this, at least when you tune them a bit, you can be able to maybe identify cells, identify like certain plants, or maybe radiology images. So yeah, that's image recognition. Now, for object detection, there's also this part where I am now using bounding boxes to now do some localization of not just telling me, hey, this is a cat, but also drawing a box around what the model has established that, or what the model is saying that, let me start that again. So the first part I just showed you, this is just classification, right? Just telling you, give it an image and then tells you what it is. But this one takes it a step further by drawing a bounding box, like a small box around what is the actual object. So this one I'll use an example of an image I found online of somewhere maybe some of you have been in Nairobi. And can anyone tell me what building this is? What building is this? Okay, that's Times Tower. So you see it's able to draw a green bounding box around it. And what about this one here? Cooperative. Okay, yeah, that's good. So maybe if this was a drone to maybe count buildings, this could, or this feature would help it do that particular task. All right, let's now switch gears to natural language. So there are a lot of natural language processing tasks. They range from things like sentiment analysis, entity recognition. That's like when you have a sentence, like the model is able to establish like, hey, like in this sentence, this is a person's name, or this is a name of a bank, or this is a name of a company. And then syntactic analysis just determining what a particular text means, maybe a part of a sentence. But the one that is very popular then and now is sentiment analysis. This is just trying to determine the emotional intent in text. So it can be a movie classification site, a movie site like, I don't know, maybe Netflix, and then I think IMDb also has those ratings, but now it has taken it a step further and you give it the sentiment of like, hey, what is this movie, like, is it this movie worth watching after maybe processing that text and knowing like, hey, this movie was interesting, it has a lot of positive reviews, and then you're able to watch it. So this can be extended to now maybe maybe it's your clients, you're trying to figure out whether the service is good or bad and what to improve on. And then maybe systems like this can help you do that. And if I run this, I have two sentences that I give it here. One about liking the Google Cloud Natural Language API, and one about you being disappointed about it. So for this, the scores usually range between 0 and 1, and if it's positive, it's more closer towards 1. That's why we have a sentiment score of 0.9 here, but sometimes you can also put like a text to say, hey, like if this thing is close to, if this score is close to 1, then it's very positive, and if it's negative, it's like less than 0, and if it's away from 0, like if it's really farther from 0, it's very negative. And you see here it's been indicated by -1. And then magnitude is a way of now taking it a step further to figure out the sentiment score. So let's just say this is another metric which you can look into the documentation and figure out what's going on a bit better. And then the syntactic analysis, like you're just now trying to figure out what's going on in the text. And this one is just breaking down the text, discovering, hey, this is an adjective, quick, and then fox is a noun, and things like those. This mostly comes in handy when you are trying to maybe curate data for a large language model training, as an example. This comes in very handy. And that's that when it comes to that section. Now let's look at analyzing the entities. Now this one usually comes in handy when you're trying to summarize text. And here, just based on this sentence over here, we are seeing a bit of Norse mythology, because Odin is mentioned here, and Gwingir, I don't think that's how it's said, but something like that. And here you're just seeing the identification of a person, and yeah, just parts of the text are being highlighted, and the types are being annotated as well. That covers entity recognition. So, the classic natural language processing section, I think I'm done with that for now. And now we can move swiftly to the speech to text. This is just converting like audio files to text. Like if you've ever heard of a model called Whisper by OpenAI, that's the open source version that people are using to make a lot of applications regarding automatic speech recognition. And Google also has one over here that we are going to use to now get transcripts from this particular audio recording I have over here. Then once that's run, you will get text over here, and you can always confirm if that audio is actually has this particular text, in case I might be not showing the right thing. And then there's the text-to-speech API. Africa's Talking uses this in their voice product, and Google utilities also have, or Google off-the-shelf models, like you have some that to actually help you do that. And here, you just give it text, and then you get audio files, right? So if I run this and give it this text over here, I can be able to play. Yeah, so if you play that, you'll be able to hear. So also I've added a widget over here. So in Colab, you are able to also add widgets and be able to interact with maybe some files that are generated, as opposed to like exporting it somewhere else and then actually using and then playing the audio file. So Colab and or Jupyter have like really cool utilities called widgets that you can use to actually interact with your data a bit better. Then there is the Video Intelligence API, which you can give videos, which are just literally just moving images, and then you're able to get descriptions about what's going on in your video. So this can come in handy maybe in video feeds for maybe factories to detect any weird changes or any weird accidents and tell the people who are on duty to kind of mend them before they get out of hand. And here the video was mostly about transport, preferably on the rail. Yeah, so to some extent, you're getting a summary of what's going on in a video using this particular model. So that's how we used to do, and probably still, all these tasks using models that are mostly used specifically for these particular tasks, for instance, the image recognition or the natural language processing. But due to how Gemini was trained and it's multimodal, that means it's able to take different modalities, meaning images, text, video, and audio, and process them. So can we do the same tasks that we've done before, but with Gemini? And spoiler alert, yes. So you can just give it the same task for image understanding, where you give it the image of the cat and ask it to give a description about what's going on. So here I'm using Gemini 2.5 Flash, and you get a description over here. This image is a humorous meme featuring a cat yelling, "Wake up, human." So that's accurate. And there's the description there. And obviously you can change this prompt to maybe make it a bit concise, or make it talk like a pirate while giving this description. And yeah, I encourage you to take advantage of changing this prompt and then just seeing what the output would be. Then we swiftly move to the natural language API. We ask the model to do sentiment analysis. And I think here the difference you're seeing is we're just giving it a prompt and then also specifying how we want the output to be. And then once we do that, and run the code, we get the sentiment of this sentence over here is negative, just due to the keywords here, bit sluggish. But this one's a bit hard. It could be neutral because of this other maybe positive thing that I might have said. But the model is good enough to figure out why. And it's always nice to have these explanations as to why the model gave that particular output. So that's some form of explainable AI in some small way. And we'll talk about explainable AI in a small kind of way. Also, just to extend my description about adding widgets and in Colab, you see here you can just maybe upload something from your computer directly from Colab. And yeah, I encourage you to explore Jupyter and Colab a lot. You can make a lot of applications which don't need a lot of bandwidth and server room. And yeah, I encourage you to explore and see where you can go with this. So here I am doing the same task for making a transcript, so speech to text, converting audio to text. And here I have a handy dandy file, And then here's the transcript that we get. Yeah. So we've moved from using the classic ML off-the-shelf models from Google to now using Gemini to do the same tasks. And now, how about we combine what we've learned so far and also integrate Africa Stalking to help someone in the Kenya Wildlife Service to determine the biodiversity of a particular place. In particular, I think it was Karura Forest, kind of simulating a drone activity as well. So I have gotten this function here for sending SMSs. Also good to have these type annotations in your functions as well. That usually comes in handy when you're doing something called function calling with these large language models. And when we run this and give it the image of Karura Forest, it's able to give us a description about the image. So let me just open the image and show you what it's about. So, wow, this is not the best way of showing it. Yeah, this one you'll have to open it in your computer. I have limited space. So apart from it didn't give me a description. That's weird. I think, did I give it? Okay. I think it's okay. I'm just wondering. So there are two tasks that are supposed to happen here. It's supposed to give a description of what's going on within the image and also draw bounding boxes within the image. And here it says the scene shows a diverse woodland with lush green broadleaf trees, prominent dead or dominant tree, including a varied ecosystem. So this description would be more, would have more stuff going on, but I think I like it like short like that, because remember you're sending this to someone and you have a limited number of characters you can send via SMS. So just continuing the theme of making widgets within Colab, you can actually put someone's phone number here in the description, and then I think there was a button. Okay. I am getting ahead of myself, but let's combine all those things we've just made, and we have a small application here where you can add someone's number there, a description, and then you click on send SMS, and you'll be able to send the SMS and even see the output over there. So, before we dive into agents, are there any questions? Thanks, Dougie, for sharing that. Okay, I am not seeing any questions. And no raised hands. Cool. So before we move into agents, for the longest time when the language models were being introduced, it was mostly text in, text out, and that's pretty much what they do most of the time. But with time, people have been able to add tooling, which is just like functions people have written to be able to make these models do other things, like do data analysis, do image recognition, or maybe do a payment to someone. And once you add this tooling to a large language model, you can now say it's an agent, because as much as it has a brain able to answer different kinds of things, when you add the tooling to now, for instance, be able to send SMS or be able to do the data analysis, maybe it has an access to an IDE, that's when you say you have an agent. But let me just move to a demo of something that you can create with okay. So this is a multi-service communication interface. So what that means is it's basically combined the functionality that we provide as Africa's Talking to enable you to send airtime, messaging, send mobile data, do voice calls, and other kinds of activities over here. I don't think WhatsApp works, but you can try, at least from the resources that were sent. So yeah, this is a kind of example of what you can do when you give these large language models access to functions. So let me just start with this one, where I'm using the DuckDuckGo API to basically help me do a search about the latest technology trends. So you see how fast it is. Can anyone guess if I'm running this on the cloud or within my computer? This is a language model that is querying the DuckDuckGo API, and it has just returned results. So the question is, am I running this in the cloud, or am I running the language model in my computer? Which one do you think? Cloud? Anyone else wants to try? Local? Pardon? Local. I could be running in the cloud. This is just the interface. Yeah, this is the interface is done, that's the local host. But the large language model can be in the cloud. So it's a local model, it's 500 MB. I don't know if you guys know that you can compress a model to be 500 MB and run it in your computer. Because this is all running in my computer and my model is 500 MB. So no excuses like, hey, these things are too big, they can't fit. Yeah? So if you look at this output here, and these links you get here, they actually, if I click them, they redirect you to something that's real. So this is an Android Police article about Samsung Galaxy S26 Ultra. And yeah, it was able to get us information about what's going on. So you can also try and figure out your wallet balance, maybe in your Africa's Talking account. And you get the gist. Yeah, so these are the kinds of applications you can make, but as much as the application is cool and all, I also wanted to show you something even cooler. So, before any prompt is processed, there is this section over here. So each prompt that so every prompt that I send to my local language model goes through some safety checks. So as much as Ian has covered some of the best practices, there are also best practices when handling like language models. And there's this library I use called Inspect AI. No, sorry, it's Inspect. It's made by the UK Security Institute. And a lot of these guys who make these large language models providers, from Google to OpenAI, use this to basically scan some of the prompts you send to their models. And there are a couple of things you're supposed to put into consideration. So number one, do you know you can street talk a model to do very weird things, like give out API keys and things like those? And if you're not careful to put checks like this, like your model has already been hacked already. I can tell you for sure. So that aspect of prompt injection, make sure you put it into consideration. And it's very hard because because language comes in, like, you can say things in so many different configurations. So at least with tools like this, you can maybe reduce that attack surface. And as you learn and use these tools, like, you'll get more, like, maybe prompts, or you can get data sets online and also put those in your kind of evaluations to be able to check these, like, the aspect of prompt injection. And then the second thing is something called toxicity. So when you're interacting with some of these models, they can basically steer you to, or you can steer towards a conversation that's very bad, that is maybe, let's say, toxicity and bias. So like it can steer you towards, or you can steer it towards very, like, very difficult conversations, maybe to do with maybe race, maybe to do with even exploitation of something. And the model will continuously just encourage you just because of how they are made. And maybe you didn't do any post, any like alignment to it. And sometimes this can lead to a couple of problems. So it's good also to look into that. I don't want to give so many examples there because some of them might be pretty sensitive to some people. So just look into toxicity and bias. And then there's the last thing to do is to do with hallucination. So to be honest, like, hallucination is very hard to look into because it has a lot of things that you need to put into consideration. Like, as I'm talking right now, I have to kind of know the English language, and I come up with words really fast. So that's some small kind of hallucination bit, if you think about it. I have to come up with words so that I'm able to talk. So pretty hard problem, right? But people have come up with ways to kind of look into that. And this one, you'll have to process your prompts to another model and then bring it back, and then you're able to figure that out. So just to summarize, it's very good to have a couple of checks or evaluations while your model is, like, satisfying user requests in one way or another. And the Inspect library is a good start. Yeah, you can maybe look for more. And you'll be able to mitigate those situations. Another thing I wanted to talk about is, I'm sure you're seeing these think tags over here. So the model I'm using is a reasoning model, yes? Oh, it's stuck. Okay. Yeah, sorry, I switched computers and I didn't do any tests when I was going through this. So the model I'm using is a reasoning model, and there are these think tags that are usually within the output. So these think tags help you kind of figure out what the model is actually doing behind the scenes. So you can think of it as an explainable AI sort of layer, because if you're able to see the reasoning behind what the model is doing, you can be able to probably mitigate some issues that you might come across or your users might come across, and be able to flag it on time and change things. So if you can use a reasoning model. And for this particular project, you can try using the GEMA models. They're a bit big, at least the ones that do function calling, whatever I'm doing is called tool calling or function calling. That means your large language model is the one that's like running the function, and you're able to do this particular task. So it's able to do tasks on behalf of you. So this is the old way of doing the function calling. So there's this new thing called model context protocol, which I'm going to cover after. No, actually, let me just show you. So, who has ever used Hugging Face before? Hugging Face. That is sad. You know why? These guys give you free servers. Like worth, how big are the servers? You're given 16 GB of RAM, 2 vCPUs. You can do a lot with this, and it's free. So I'm doing the same over here. So make sure you check out Hugging Face. Yeah, you can write a lot of projects in your portfolio and just put them there, and possibly share it with potential employers. So this is the same like interface we had before with the Gradio. So I'm using a library called Gradio to make these user interfaces, and people who do a lot of machine learning are pretty lazy writing these user interfaces, because writing like generative pre-trained transformers or very complicated models is a lot of work, and making user interfaces is really hard. So people have made this library called Gradio that helps us make these kinds of UIs in a very like friendly way. And this is the model context protocol that I made for the other application I showed you. So the cool thing about this one is I can expose it to different services. Like if I wanted to have Claude, maybe help me send SMSs or airtime or do the, to send a WhatsApp message, I can just give it access to this MCP I have here. And if I move this and click there, you can see that Gradio helps me make like the API documentation in different flavors, Python, JavaScript, and Curl. And for the MCP, if you have this URL and put it in maybe your Casa, your VS Code, your Claude, you can be able to do the same things like send SMSs, send airtime, send mobile data to people, or even do voice calls as well. And remember, this these are just functions. You can just write them and then put them in this kind of server, and then your large language model will be able to run them for you. So maybe you can try the SIP that has been mentioned quite like a number of times by other speakers to be able to make one of those conversational agents like ChatGPT voice. Oh, I think I ran this before. Cool. Now we can move to ADK. So, also in the Colab, you can actually embed whole websites using this magic HTML and a bit of some HTML syntax here, and I can embed a whole web page here and actually interact with it as if I am browsing within the cell, which makes it neat. So I don't need to switch context. I can just do all my work over here. I don't need to jump in the web browser and switch. I can just do it all here. So isn't that cool? But anyway, let me switch to VS Code here. And please let me know, like also in the community page, if I'm actually showing my code, because I have a tendency of forgetting. So can you also see this in the page? Good. So with ADK Kit, it helps you make agents really, it has all the ingredients for you to make agents like easily. And there are a couple of frameworks that you can use as well to do this. And right now, I think yesterday there was a session about ADK Kit by someone. I think maybe just check the YouTube channel for Africa's Talking and see what he covered, because he covered the first part about this. Mine is very superficial, but within the documentation, within the notebook, within the repository, I'm going to make some changes like in a couple of days and make this a bit better in terms of evaluations. But let me just run the user interface for the agent framework. And a bit of what I said before, that's really dark. Yeah, so a bit of what I said before about evaluations, there's a tab for that and you can look into it. There's also, there are a lot of interesting things that you can look at, like tracing conversations, just seeing the back and forth between a user and the bot and trying to figure out whether the bot is doing the right things or not. So you can just say, So the cool thing about the model we are using here, it's able to take different modalities. I can give it audio, I can give it like images, and it'll be able to process it. And here I'm using a model in the cloud. I think it's Gemini 2.5 Flash. And I just ask it what it's capable of, answering questions, translating languages, running code, engaging in conversations. Like we can ask a question like, does anyone know something recent that has happened that I can test it with so that we confirm it's not hallucinating? Oh, someone's talked about Cloudflare. And I think you've noticed I'm making so many spelling errors. That's okay. The model will be able to figure out what I meant. Okay. So as you see, when we are doing the conversation, we're able to sort of trace what's going on, the invocation, how long it take, what you call the model, how long it took, and you can see the text also that comes out as well. So it makes it very easy to trace what went on, if it used a particular tool, and you can even show it in a graph. And yeah, it's pretty tool rich. So I'm actually liking this interface for ADK Kit. And again, if you want more information about this or to basically grok this, you can look at the code labs and the sessions you're going to have with particular experts in this. So let's see what was brought up, what came about. So I'll just paraphrase this because it's pretty long. So Cloudflare experienced a significant outage on Tuesday, November 18th, 2025, which disrupted access to numerous websites and online services globally. The widespread issues led to internal server error messages for users trying to access sites that rely on Cloudflare's infrastructure. There are a couple of companies which were affected: X, ChatGPT, OpenAI, Spotify, Square, and yeah, that is, at least from the last time I looked at news a couple of days ago, that is accurate. Cool. Yeah, so you can make an agent like this with ADK. Obviously, you can make it a bit sophisticated and do other things apart from, because here I'm just using a single agent that's grounded with web search, and usually a way of mitigating hallucination is adding search, or that's why I've been showing you search, like with the DuckDuckGo API and here with the Google Search API, so that you can be able to mitigate that hallucination effect by adding just search, Google search, in this case. Great. Also, in Colab, there is a table of contents, like with these 3 dots here, that you can be able to kind of scroll up and down to jump between sections and be able to effectively like utilize the notebook. And here we are at Model Context Protocol. So now this is the evolution of how to add tools to your large language models. And this one is a bit more disciplined compared to what I showed you before. Because what I showed you before, you need to keep on writing those functions over and over and over and over and over again. If you want to put stripe, you have to write the function. If you want to put this, you have to write the function. But the good thing about the model context protocol, you can think of it as a USB-C for connecting LLMs to tools. And you can now find, like, there are so many model context protocols like online to do various things. And I don't have to write that functionality over and over again if I can find a model context protocol for it. So, like I showed you before with my example, where we used some of the Africa stocking functionality to make my own MCP server to interact with Africa stocking services. Here I have one that I'm running in Colab, just to demonstrate that there's a terminal, because people forget that you can do things like a lot of things within Colab. So let me just run this Python function, which opens up a server for the model context protocol for determining currency. So if I run that, okay, our server is up. So if I wanted to do a conversion of 1 USD to euro, I can just run this. And in Colab, there is this exclamation mark Python. This means it'll run your Python interpreter with this particular file. And this is just a test. And as you can see, the API response was successful with other tests. And there were 3 tests, and they passed. So that's good. So here I'm using a library called FastMCP to run the MCP server. And I'm happy with the results. And I'll turn it into an MCP utility. So a task you could do is you can try and write your own model context protocol, because at least from using the example I've given there within the notebook, I think that's good enough to help you get started writing your MCP and trying to interact with Africa stocking services. Because the one that I just showed you is a private server, and you need to be authenticated to use it. Or you can talk to me, you can try and switch talk me, and then I give you the code. But I prefer you do it yourself, because you'll learn a lot about making MCP servers. So, just because of time, the agent-to-agent protocol, I'll try and add an example. It'll take me some time to explain, but in general, the agent-to-agent is just a way of communication between agents. You can maybe use different frameworks like Crew AI. So that is the main bulk of what goes on with agent-to-agent protocol. And there's also agent-to-payments, which now has the aspect of, can agents now actually do payments for you? And these are very new services, to be honest, just looking at the source code. But I'd say maybe look at their examples and try, and you can be able to maybe appreciate some of the work that has been done here and see how you can integrate it into your work, or also contribute to the library, which will also give you a lot of visibility of your portfolio. So, apart from running models locally with what I showed you with a tool called Olama, which helps you run LLMs offline, there's also this tooling called WebLLM, which runs models in your browser. So there's no information that is leaked out. And you have a couple of models here that you can choose from Llama, Gemma, from Google, and there's the stable LM from Stability AI. So Let me see if this browser will be able to run or load the model on time, because it has to download the model first. So let me just remove my session here, and then I say, hi. Yeah, I don't know, there is something wrong, or this is not the best way to run this, but if you use this URL, you can be able to interact with this bot better, or this bots better. So here it's actually going to load the model within your session, and you'll be able to interact with it, and maybe it can be able to answer some of your questions. Yeah, this is just not running, at least with this browser. So if you wanted to check the agent to payments protocol, I think you can use this link to go there and run it. Otherwise, you can also run Node within Colab, like I'm trying to run over here, but it seems I kind of skipped a step. So that's why you're seeing all these errors here. But again, I've provided the link to what I was trying to do here. It's a to-do list app that is powered by a large language model, Gemini, to do a couple of things. But that is my speed run, or model 7 to 10. And I think that's all I had for you, unless you have questions or feedback. All are welcome. Okay, there's someone with a question.
It's more feedback. Thank you. It's been a wonderful session. I just noticed on the notebook, the MCP section is missing. Is it because I haven't?
I change these notebooks like daily, and the one that you put that is you have access to is an iteration I did in the past. Yeah, so it'll be updated. Yeah. Oh yeah, so the Hugging Face demo, like I said, it's private. Yeah, it's private because I wanted you to try and replicate it, because you have all the tooling. I've given you a whole repo where I've written all the code that I use for AT to get access to all these services. And also when you're making this tooling, I suggest you write your doc strings, because if you don't write doc strings, the model is going to get confused and you won't be able to run your code. Yeah, so the people who don't like writing documentation, you're in trouble. So any other person who has a question, feedback, big up? Big ups are also needed. Okay. Cool. If that's that, then I think I can move to MK to maybe give some final remarks, or we can now have our mandazis at the back there, or our evening tea, or coffee, or what you like.
Wonderful. Thank you so much, Maine. That was great. A few things. I want to give T-shirts, but I see the guys who are super active now. They are gone. How they're gonna get T-shirts? Anyone who has completed the badges? Anyone? I want to start with those ones. Any person who has already completed the badges in the room? All right. You have? Even if you have completed today, if you have completed a lab, you get a badge. So that's how you get the badge. So each badge was getting a T-shirt. So if you have completed 5 badges, because you're not as many, you could have gotten 5 T-shirts, different sizes if you want. Okay. So I want my speakers to give me a few people to present with this. There's someone who was chosen by Ndocha. Is it her? Yeah? Yes. How was the session? How was it? Good? Yeah? Now you see like you can tackle all the labs, isn't it? Yeah, so we'll have another session in February, the final. That's why now we'll give the cash prizes. Don't miss that one. And if you can finish by December, even better, because now you'll perfect on your project. So if you finish all the labs and all the 10 modules by December, which is like 2 weeks away, thank you so much. Then that means you'll be able to perfect your project between now and February, and you should be able to stand out when it comes to the giveaway. Sasa. Now, give me guys I should give the T-shirts. Who are very proactive. Who are you counting? I can't see who you're counting. Him, huh? Madam? Uh-huh. Your name is Jocelyn, right? Yes. Uh-huh. And who? That's the interesting aspect about it. So, Jocelyn, what's your size? Medium, not large. Medium. So Jocelyn she's from Cameroon, which is super cool. And to see her stay all the way, that's a great. Give her a lot of applause to her. Come for it, please. Yeah, and she's super excited. We had a chat. She wanna, start a community back at home. So yeah, at least you have something to show. Yeah. What did he ask? Yeah. Okay, SMS API, how to set it up. Uh-huh. And it was successful. Were you able to send an SMS? Yeah? You're confirming it went through. Say that went through or not. Was it on Sandbox or live? Yeah. So remember, you can actually request for a test send ID, which is free for devs, but it's valid up to 7 days, all right? So in case you want to test it live or when you're showcasing your project, you can request until the end of the program. It will only last 7 to 14 days. Depending on which product you ask or you request, it will last between 7 to 14 days, all right? Yes. Come for your t-shirt. Which size? Medium. Yes, come for it. Ian, who should we reward? Who should we reward? Who was proactively engaging? Give a lot of applause. What's your name?
Odalo.
Odalo. Give a lot of applause to Odalo. Ian? Who? Him. What did he ask? Yes. Yes. Yeah. So anyone on, or the people online are the people in here? Is that the case? Ah, so no one who is online who is not here. Is there anyone? I am sure the guys online can hear me. No? Guys online, can you hear me? Yes? Jesse? He has raised his hand. Oh, he's not here. No? Jesse Kidula is here. Oh, he's there. Yeah. So sorry guys, we normally send Uber codes where Uber exists, so we didn't send for this event, but not to worry. Keep participating. I know of people who have been active on this project, who are not here apparently, and even they have completed some labs. So this is gonna be fierce, man. You better put in some gas and ensure that you are doing a wonderful job, all right? Yeah, come for your t-shirt. Which size? XL. No XL, Dagi. Only large and, in fact, most of them are large. Yes. Two people. Who do you choose? Which lady? Joy. We are sure she has not told you you must give me a t-shirt, Mainya. You can't leave me like that. Really good questions. What did you ask, Joy? I'm curious. What did you ask? Or you gave feedback? Which feedback is that? I'm curious. Ah, okay, okay. We should delete it. We should delete them, or what was the feedback? We should? Or they're outdated? Wow, wonderful. No, it's now updated. The other should be updated. Okay, all right. Which size? Medium, medium, large. All these are large. Large is fine. Blue, black. Yeah. Who else? The problem, they went home. You know, Nairobi traffic is a bit interesting. Or maybe people are getting into their now day job. Okay, here it's night job, but somewhere else it's day job. You know devs, eh? The remote work. Yeah. Are they around? They're not around, right? Mine? They're not, okay. Who else deserves a t-shirt? There are people who came really early. There's a guy who was seated here all along. Who was it? There, I think there or somewhere there. It's you. You are there early in the morning. Both of you, or you, there was one person. It was him. Okay, which size? Large? We don't know which size you wear. I think large should be good on you. This looks like a good size for you. Someone was looking for extra large? See, that's the only one remaining. Okay. Yes. Anyone else who have not received the t-shirts? Yeah. So 1, 2, 3, 4. Okay, he has received, right? 3, 4, 5. Okay, I'll give the rest, but it's just large. For staying all along, that counts for something, isn't it? Can come for t-shirts. Come. If you haven't gotten a t-shirt, comes for one. Daughter, are you done? I have your t-shirts here. Is it large? No, where's it? Large. Large leg. Hebu jaribu. Easy fitting zake ni ndogo. Fitting zake ni ndogo. Shika XL usiende ukisema hii ulitoa tu. Kulikuwa na wengine wameshika. Kemi, mtasaulika. Haya, kujia Kemi, ende Kashingiri. Wewe umechelewa. I have only two remaining. Large, right? These are our designers. They're the one who came up with this design, right? Unavaa gani? Kuna Excel imebaki? Okay, guys. I don't know if you have a question before we wrap up. Any question? Feedback? Yeah. Again, sorry for starting a bit late. We didn't want our online guys to miss the experience that you have here. And thanks for the media guys. You have really done a good job. The quality is superb. And also, so I hope the online people who are also present, you've had a good experience in the house. But also, all these videos are recorded, which is a good thing. So you can always go on all our social media and pre-listen in case you miss something and ensure that you get everything that was covered. Having no further words, maybe Graham, you want to close this? Oliver, are you doing live interviews? I don't know.
Hi, everyone. I hope you enjoyed the session. Today we had someone from Cameroon. I hope you made some friends. Yeah. So this is very good. So as we have mentioned severally, I think many times, we have money for you guys. Up to $5,000. But you have to finish your capstone projects. I think the main way we'll do it is that you will vote for the best projects. Yeah, that's how we do it, guys. This chief is surprised. Yeah, that's how we do it. So you guys will vote for, you guys will submit your, Chief, I don't know, we don't have a criteria yet, but probably you have to finish your badges. To finish your badges, then your capstone project. It's $5,000. So I don't know, should we say $100 per person? You guys will also tell us. Join the Slack channel and tell us what we should do. But there's $5,000 to give for the guys who finish the capstone projects. How the hackathons or the workshops run, I think MK and Sylvia will tell you guys. But that's a lot. So make sure at least you finish your capstone project. You have liberty to think about what you want. Yeah, we're not going to be like, oh, you have to have done it this way. Ideally, you just have to have incorporated all these workshops that you're doing here, which means you have to finish the badges. But there is cash, guys. So, yeah, so don't give up. And we're not going to be the ones to judge. All of you guys will join a call just like this one. In the final, we do it in the final day. Yes. And we don't usually, that day we don't usually send you the money. We carry it here. You come and shake the hand and take the cash. I'm serious. So you guys have the blessing that it will be in Nairobi. However, the guys will be outside of Nairobi. As long as they've submitted their capstone projects, finished their badges, we won't tell you whose project that is, but you guys will look at all of them and we can judge and say, this should be number 1, this should be number 2. We should also decide how many numbers are we giving. Are we giving top 50? So everyone gets $100. Should we do top 10? Everyone gets $500. Let the conversation begin, guys, but that money exists. Have a wonderful weekend.
Yeah, but I have a controversial criteria. So there are 3 cities, that is Joburg, Lagos, and Nairobi. I was of the opinion that top project gets $1,000 cash. Second project gets 500. That gets 150 in each city. How is that?
Now, you see, let the debate begin.
Right? Because if you say everyone gets something, definitely everyone gets something, maybe swag, maybe experience, maybe skill. But ideally, the top guys, you have to put in the work. And you see, it's not MK. We will not have a panel of judges. I know most of you maybe you'll be used by a panel of judges and all that. All we can help with is just sieve like the best projects so that they can be presented. But even then, we can say all the projects that are complete, let everyone have their day, right? What do you think? That's good? Fair? So be sure. If you build, also you are able to judge and say this project, for sure, encapsulate everything that was shared in this program. And the beauty of it is if you have completed all the labs, definitely in there you'll get some rewards. Already you guys have gotten t-shirts, right? So these are beginning, and these are second in-person event. As we said a few months ago, the virtue is just to complement the in-person. So it's not the other way around. The virtue is to complement the in-person. So if you're really keen on the virtue and you're taking those labs by yourself, it means by the end of this program, you'll have a lot to learn. And remember, the key goal of this program is for you to learn how to build on AI. So that's why Ndocha will share Firebase, Kai will share ADKs, Misola will share SDKs and how to build on it. It will share Marketplace, it will share their APIs, and so on, so that you get all that knowledge and have the ability to build scalable, robust solutions. All right? Does that make sense? Yeah. And if it's overwhelming, go on Slack, let other people know you are stuck, ask questions and all that. So without further ado, thank you so much for your patience. Until next time, my name is Michael Kimathi. You can stay and network for like an hour. We have some tea and snacks. Yeah. Bye.